Okay, so in the end, we haven't talked about what is a data stream actually. We talked about batch learning. We talked about the problem that the batch learning scenario is not the perfect scenario for streams, but what is the streamed scenario actually? Well, stream scenario is obviously the scenario where data arrives, new data arrives at specific time slots, and the data evolves over time. Yeah. So we had this saying here, or this quotation from a Greek philosopher. So that is why you see that our former colleague Irene Tutsi, who is Greek, so she came up with this very nice saying here. So everything flows, nothing stands still. Also, the Greek guys already knew that before before zero, so to say. So data evolves over time because data is arriving over time, and old data may become irrelevant, obsolete, or whatever. Yeah, so we are probably only interested, or the data that arrived recently is probably much more interesting, much more relevant to our patterns than the data that has been arrived, I don't know, a year ago or something like that. Yeah, and we can distinguish between two scenarios: dynamic data arriving at a low rate, for example, in a periodical manner, such as, and in this case, you are in the typical data warehouse environments. So the data is coming into the data warehouse over the weekend, and then incremental methods might work for such cases. So the data is coming in on Saturday, and then you're running all the dashboards and the processing and the ETL, of course, for the data warehouse over the weekend. And on Monday, the data warehouse is up to date, at least for the week. Yeah, and then over the week you collect all the changes and you bring in the changes into the data warehouse again on the next Saturday. Yeah, so the data warehouse is up to date on Monday, and then it gets outdated over the week, and then it's updated again on the weekend, and so on and so on. Yeah, and of course you can have shorter time periods, like every day. The data warehouse is updated every day or whatever. But this is still a traditional data warehouse scenario where incremental methods are okay. Data streams are a little different. So this is the second class of, or second scenario. You have a possible infinite sequence of elements arriving at a rapid high rate, a very high pace. So new methods here are required to deal with the sheer amount of the data that is coming, because it's coming fast, and of course also the complexity of this amount of data which is coming fast. Yeah, so so incremental methods typically do not work anymore. What are incremental methods? Well, incremental data mining algorithms typically focus on how to update the patterns that I have currently based on newly arrived data. And we typically, or incremental data mining algorithms typically try to do that without recomputing the whole patterns from scratch. And as I said, that is the typical data warehouse scenario. Those methods still requires access to the raw data, typically limited access to the raw data, but in the worst case, they have to access all the historical data. Yeah. So, but still, those incremental methods try to only access the data that is affected by the changes. So here is a very prominent example. You can look up the original paper if you want. It's a nice paper to read also, is an incremental version of dbScan. Yeah, so what happens to the dbScan cluster if a new point is coming in? Well, you can nicely break down the things that can happen if a point is inserted, or even if a point is deleted from the data set, into specific cases which can happen. Well, the point can break some connections, so a cluster may split up in so if you delete a point, a cluster may split, or a cluster may disappear, stuff like that. Yeah, but typically the recomputing of the pattern recomputation of the patterns is only limited to those clusters that the point that you insert or delete is in. Yeah? So, for example, if you insert this new point here, this may have an effect on this cluster here, but this has no effect on those clusters down here. Yeah? And that is the nice thing in dbScan. So the incremental version of dbScan requires access to the raw data, but only to that part of the data that is affected by the changes. And there are other methods, other incremental methods similar to dbScan, incremental dbScan, that work for k-means or whatever. Yeah? Okay, so now coming to the interesting point, what are the challenges for data streams? So data mining over stream data is much more challenging than batch learning, because you typically have a much higher amount of data, and only a small amount can be stored in memory and can processed at a time, because the arrival rate is quite high. So you don't have much time for processing, because if you need an extensive processing for your data which has arrived at the last time slot, you process and you process and you process, and at that time or during that time new data already arrived. So you only have the arrival rate for processing, and the arrival rate is typically very small. So there's not much time for processing the data. So typically you only have one look at the data at each data slot, because the next is coming. Yeah. So all the data stream algorithms are typically one shot or one look algorithms, and even that one look and that one shot should be quite efficient, because you don't have much time for that. Yeah, and the generative distribution of the data set of the data stream might change. So that is the evolving of the patterns of the data distribution. So you want probably to adapt and also to report on the changes, on the evolution of your data streams, of your patterns. So here are the requirements for stream mining algorithms. You have to use limited computational resources. You have a bounded memory typically. You have a small amount of available processing time. This one look, one shot algorithms, but still this one look should be quite efficient. And you also have no random access to the data. It's just, you just have access to the data as it arrives. So in the order, in the historical order of arrival. And as I said before, you only have one look. So so there is no random access to the data. You cannot somehow say, okay, now I want to have the Epson range query of this and this data set. You cannot compute that during the stream processing. Yeah. So limited computational resources, no random access to the data. That's the most important. Those are the most important requirements for data streams.